Okay, so let's start by doing one thing really quick at the top. Let's go back in time to when we first started learning fractions. If you wanted to add the two fractions, 1/2 plus 3/4, what do you have to do first?
Make them the same.
Make them the same what? Common denominator, yes. We call that the LCD, which stands for least common denominator. I really honestly don't care about the least common part. As long as you get a common denominator, you'll get there. So my least common denominator between 2 and 4 is 4, yes. So what do I have to do to the 1/2 to turn it into fourths instead of halves?
By 2.
Yes, on the top and the bottom. And we're going to be doing that today, except it's not just going to be multiplying by a number, it's going to involve some variables also. And then once I do that, I get 2/4 instead of 1/2. And what is 2/4 plus 3/4? 5/4. Yeah. So when you add the two fractions together, you add the tops, but you do not do anything to the denominator. You just keep it the same, because it should already be the same number. That stuff is going to get a little bit tricky today, which is why I wanted to kind of show you that that's how fractions work, or remind you that that's how fractions work before we get into some of the complicated stuff. So step 1 is to find a common denominator and make it happen. Step 2 is to combine the numerators, but keep the denominators. Okay? Combine the numerators. That means add, basically. The only reason why I didn't use the word add is because sometimes we're going to subtract, which is the same thing as adding, it just goes down instead of up. And then the third step is going to be to simplify. The other note we're going to make up here before we start our problems is always factor denominators. They have to be factored, otherwise you won't be able to see what your common denominator is. And one other thing about this is you don't want to unfactor them. You want to keep them factored so you can see what crosses out. There is only one thing that we will actually multiply together, and that is the numerators, and I'll show you why when we get to an example that has it. As we start to look at this first example, you should notice that while the denominators aren't super nice, they're the same number. What that means is, or same expression, they're both n squared n minus 6. N squared n minus 6. That is going to be the denominator of your fraction once we put them together. You don't change the denominator. But the top part, we're going to subtract because there is a subtraction symbol right here. Common or like terms. So n squared, there's no other n squared over here, so it just stays. But then I can do 3n minus n, which is 2n. And -7 minus 1. That one's a little tricky. It's actually -8 because you're subtracting 1, not adding 1. You're subtracting for the whole problem since that's what's here in the middle. And then this is the part where the factoring comes into play. The only time you actually have to factor on this problem is we're going to find the two numbers that multiply to -8 and add to 2, or -2. And on the bottom, what multiplies to -6 and adds to 1. 3, -2. So that we can cross them out. And this is our answer. And that's kind of how the setup works. The only difference is you don't always have the same denominator. So as I start looking at the second one, I'm just focusing on my denominators for a second. This one has an a squared. So I need to multiply this one by a so that it also has a squared. But I can't just do it to the bottom, I have to do it to the bottom and the top. Then the one on the left doesn't have the 8 in front that this one has. So we have to multiply it by 8. And now they both have 8a squared on the bottom. And that is kind of how you figure out what the LCD is you just figure out how do I make this look like this and this one look like this one. And then because I know that a lot of times part of the hardest part is just how many steps things take, we're going to go ahead and do some work right up here for a second. 8 times 4a is 32a. Minus 7 times a is 7a. And 32a minus 7a, 32 minus 7 is 25. And then you're going to check and see 25 and 8 don't divide by anything together. So that has to stay. But you can use this a to cancel out the squared. So 25 over 8a is your final answer. And the only reason we're going to do a couple more examples is just to get used to some of the factoring. That's pretty much how these work. If the denominator is not already factored, you have to factor it. So like this one, the k minus 2, it's fine. But over here, I have a greatest common factor I can divide those by, and it's 5. The reason why that's such a crucial step is because when you divide them by 5, you get k minus 2. And I'm going to cross out the not factored version because we don't need it anymore. We already factored it. What is the only thing that this side is missing that this one has? The 5. So we're going to multiply that right here. And the only reason I'm writing it on that side is so it looks identical or on the same side as the 5 on the other one. So then my new denominator is 5 times k minus 2. Don't multiply that together. Some of you are going to want to because we're used to it. Keep it factored, otherwise you won't be able to see what cancels. On the top, I have k squared plus 16 minus 20. Or k squared minus 4. The top part is the only part where you actually have to add or subtract something. And we're not quite done yet because we do need to factor this. And there is a factoring flowchart on the back of this set of notes, and it looks like this. If there are 2 terms, there's only really one way to factor it. You're either just done, or you use difference of squares. Difference of squares is where you have 2 perfect squares being subtracted. The subtraction is called a difference, and then the squares comes from perfect squares. You just find the square root of these 2 and make one a plus and one a minus, like this. And that's what we can actually do with our problem, because k squared is a perfect square, and so is 4. It's probably one of the shortest ways of factoring, but it's easy to forget about. And since the square root of 4 is 2, it just becomes k plus 2 and k minus 2. And again, the whole reason you have to factor is so that you can see what cancels. Those x minus 2's are going to go away. And we just have k plus 2 over 5. Yeah. if you happen to see one where they both have something like this on the bottom, this is probably going to be one of the factors of this. Because when I go to find the factors of this, I want two numbers that multiply to 24 and add to 11, which is 8 and 3. That makes the problem a little bit simpler because the only thing that the fraction on the left is missing to have a common denominator is y plus 3. And I'm putting it on the top and the bottom. It doesn't really matter if you write it on the bottom because most people see that they're going to have that as their new denominator, like that. So whatever you found gets to be the same, that's what stays on bottom. And on the top, we have to do some combining. This is the only time you will multiply. I have to multiply this 7 all the way through so I can actually add this 35 to something. Otherwise, it's just kind of stuck there on the side. So basically, I'm trying to do this. And I can't put that 35 with anything unless I multiply it out first, which will become 7y plus 21 plus 35. And the whole goal is that now I can add these two together. And 21 plus 35 is 56. And now we have our fraction, we just have to simplify. These numbers are pretty big, which means there's probably something we can divide them both by. We can actually divide them both by 7. 7y divided by 7 is just y. And 56 divided by 7 is 8. So then you can cross off your y plus 8s. Boom, boom. And there you have it. And then we are going to do the bottom right one. So I'm going to skip this one because it's not that different. We'll do this one and then number 14 on the assignment together. And then I'll give you guys some time to work. Okay, so I'm going to go through this one a little bit faster since it is our 5th example. This part right here, m squared minus 4. That's the exact same thing as k squared minus 4 was. That's a difference of squares, m plus 2, m minus 2. Which means the other one is just missing the m plus 2, because it already has the m minus 2. And now they match. So on the bottom of my new fraction, I'm going to have both plus 2 and minus 2 within my parentheses. And on the top, this is where I'm going to kind of do it more like you might do it on your assignment. Normally in notes, I take my time and do every little step so you guys can see what's going on. This time, I'm going to go ahead and multiply these together, which makes 2m plus 4. And before I even write it down there, I'm going to go ahead and add together 2m and 5m, 4 and 6, and leave the m squared out front. If you can kind of think through the problem and solve a few steps like that without having to rewrite every little thing, it's going to make it feel easier to you. And now all I have to do is find two numbers that multiply to 10 and add to 7, which is 2 and 5. And my m plus 2's cancel. Like this. So that's your answer. Okay. And the reason why I wanted to do 14 is because it is one of our factoring problems that looks like this, where you have a number in front of x squared, so what you have to do is split up the middle. This is a very specific type of factoring that only happens in this case. Otherwise, if there's not a number in front, that's what I've just been doing, where you find two numbers that multiply to the last and add to the middle. So, on the back side of the assignment, number 14 has that same kind of setup on the bottom. So this problem just gets to be a little annoying. It's not that it's really difficult, it's just kind of a pain in the butt. So in the middle, we need to find two numbers that have to add to 14. Otherwise, we're kind of breaking the rules. But we want them to multiply to 3 times 8, which is 24. And 12 times 2 is 24. So that's 2a plus 12a in the middle. Then you have to split it up and say, okay, what can I find that goes into these two? And that is a. No numbers, just a. Leaving you with 3a plus 2. And then in the second half, you can divide them both by 4 over here. And you have 3a plus 2 left again, which is supposed to match. The final step of this type of factoring is to write it with the 3x or 3a plus 2 out front. And when you do that, you're saying that it's a GCF. So you cross these out, and the only two things you have left are a and 4. You just got to put a plus sign in between them. That is the factored form of this. It just takes a minute to get there. And then comparing my denominators, this one is missing the a plus 4. And you actually have to multiply that out on the top. 7 times a is 7a. 7 times 4 is 28. And then we add 8a and 7a makes 15. Okay. And negative 18 plus 28 makes 10. We do want to see what factors cancel out. Thankfully, because this one was more difficult, all we have left is to divide these by 5. That leaves you with 3a plus 2. So you can cross off the 3a plus 2. And 5 over a plus 4 is your final answer. Something on each problem is going to cross out like that. There shouldn't be very much left at the end.